Good evening, everyone. So today I'll welcome you all to the week 11 live problem solving session in NPTEL Mathematics Algorithms and Applications course. So this week I'll be taking through the summary of week 11, which includes awk programming and computational methods that are used in mathematics and sample problems that are related to awk and as well as machine learning. So to start with awk is a powerful text processing language that allows you to manipulate and analyze text from various sources. awk is designed to work with text files and other text-based data sources. It can read data from files, pipes, and command output. And it is also a versatile tool for text processing and data analysis that is widely used in Unix and Linux environments. awk provides a range of built-in functions and operators for performing complex data processing tasks. awk provides a wide range of built-in functions and operators that allow you to perform complex data processing tasks with ease. These functions include string manipulation, math functions, data conversion, and more. You can also define your own functions in awk to perform custom operations. awk supports regular expression for pattern matching, which make it useful for searching and replacing text. Regular expressions are the powerful tool for searching and replacing text. awk supports regular expression, which allows you to search for patterns in text data and replace them with other text. This makes awk a powerful tool for text processing and data analysis. awk programs are structured around patterns and actions. awk programs, a pattern specifies a condition that must be met before the action to be executed. An action is a sequence of commands that are executed if the pattern is matched. This allows you to selectively process data based on specific criteria. A pattern specifies a condition that must be met for the action to be executed. An action is a sequence of commands that are executed if the pattern is matched. An action in awk program is a sequence of commands that are executed if the pattern is matched. Actions can include reading or writing data, performing calculations, and many more. This allows you to perform a complex data processing task based on specific criteria. awk provides a range of built-in variables that can be used in your programs, such as nr, which tells about the current record number, nf, the number of fields in the current record, fs, that is the field separator. So awk can be used on the command line or within a script file. To run an awk program from script file, you can save the program to a file with a .awk extension and then run it using the awk command. Just one second. So here some of the things that can do with awk. First is search and replace text. awk provides powerful regular expression support, which allows you to search for specific patterns in text data and replace them with the other text. This can be useful for tasks such as finding and replacing specific words or phrases in a document. Next is extract data from files. awk allows you to extract specific data from files based on various criteria such as column or row numbers, field delimiters, or irregular expression patterns. This can be useful for tasks such as extracting specific columns from a CSV file or extracting data from log file. Third one is transform data. So awk allows you to perform a wide range of data transformations such as converting text to uppercase or lowercase, or removing or adding characters, or reformatting the text data into different structure. This can be useful for tasks such as data cleaning or preparation. Also, awk allows us to aggregate data based on various criteria such as grouping data by specific columns or summarizing data based on specific conditions. This can be useful for tasks such as calculating summary statistics or generating reports. Awk supports processing structured data such as data in CSV, JSON or XML format. This allows you to manipulate and analyze the structured data using awk's built-in functions and operators. Awk can be used in combination with other Unix tools such as grep, set and cut to automate the complex data processing task. This can be useful for tasks such as data integration or ETL processes. ETL process means extract, transform and load. So this awk commands can be used in a wide range of scenarios. Its built-in functions, regular expression support and flexible data processing capabilities make it a popular choice among the users. So as I mentioned previously, awk is a command line tool used for text processing and data manipulation. It is commonly used for parsing and transforming structured data such as CSV or log files. So here I have given some of the basic examples or basic syntax for awk. First one is awk pattern action and file.txt. So in this syntax, pattern specifies a regular expression or condition that matches the lines of the file, and action specifies the action to be taken on the matched lines. So this awk programming uses various symbols to perform different operations during the text processing and data manipulation. Here are some of the most commonly used symbols in awk along with their meanings and examples. First are the curly braces. The curly braces are used to enclose awk commands or statements. They are used to define beginning and end of a code block or a block of code. For example, here I have given awk in curly braces print $1 and $2 of file.txt. In this command, the curly braces are used to define a block of code that prints first and second fields of each line in the file.txt. So $1 and $2 represents first and second fields of each line. Then we have forward slashes. The forward slashes are used to define regular expression or patterns in awk. They are used to search for or match specific text in a file. So the example command where the awk /pattern curly braces print in file.txt, the forward slashes are used to define the pattern, which is then used to search for lines that contain this pattern in file.txt. So $sign. As I mentioned before, the $sign is used to reference a specific field or column in awk. It is used to access or manipulate data in specific column or a field of a line. So similarly, the command here, the $sign used to reference the first field of each line in the file.txt, which is then printed. Then we have double equals to sign, that is two equals to symbols side by side, which is used to test for equality in awk. It is used to compare two values or expressions and returns true if they are equal. So the command here checks The double equal to sign is used to compare first field of each line in file.txt with a string hello, and command prints the lines where the first field is hello. So if this condition $1 equals to hello satisfies, the line gets print. Then we have f, that is called dash f. It is used to specify a field separator in awk. It is used to set the delimiter used to separate fields or columns in a file. So in this last awk command, the file format is .csv, so which ends with comma separated. So f is used to set the field separator as comma. So in the command you can see hyphen f. After this, a comma is placed, which denotes the file format. These are just a few examples of the symbols used in awk and their meanings. There are many more symbols and operators that are available in awk that can be used for various data manipulation tasks. So here I have provided some of awk one-liners. So first one is so before moving on to one-liners, I have some more references to tell. So these are $n, which refers to the nth field in a record, where field is a section of record separated by delimiter. Or if we consider a CSV file or Excel file, a field is the value in a row, the row value. $1 is row 1, $2 is row 2, $3 is row 4. And we have NR, which refers to the current record number. So here the second command, that is print NR and comma $0. This command prints the line number and full record of each line in file.txt. And we have NF, which refers to the number of fields in current record. So this command under this NF prints the number of fields and full record of each line in file.txt. Then we have begin and end, a special pattern that is executed before processing any input records. So this command prints like the code start processing, like this is a header printing. And similarly we have end, so where a special pattern that is executed after processing all the input records, like this is a header footer message information that we get once the code gets run. Yeah, similar to hyphen f, fs also refers to the field separator used to split records. Then we have OFS, which refers to the output field separator used to separate fields when printing output. So then pattern I have discussed. So $0. So $0 refers to the entire record, that is entire line to print. So here I have questions. So what is awk primarily used for? I'll wait for a minute or two. Whether the awk is used for image processing or whether the awk is used for text processing or data manipulation, whether the awk is used for video editing or for audio synthesis. As rightly mentioned, awk is a powerful tool primarily used for text processing, data manipulation tasks such as searching, extracting, transforming and formatting text. So, which symbol is used to specify field separator in awk? Whether the and symbol, star symbol, dollar symbol, or hyphen F is used as a field separator in awk. The question here asks for what is the symbol used to specify field separator in awk, whether it is and, star, dollar, or hyphen F. So here hyphen F used in awk to specify the field separator, which is used to split records into fields. So here I have a set of questions. First one is what is the default field separator in awk, whether it is space, tab, comma, or new line. Next one is what is the syntax to print a specific field in awk, that is print field number or print hyphen dollar field number, print field underscore number dollar, or print dollar field underscore number dollar. Third one is which of the following is an awk inbuilt variable, nr, var, $1 or cmd. Fourth one is what does awk command begin to do? Specifies the patterns to match, executes a command before processing input, executes a command after processing input, or terminates the awk program. Fifth one is how can you print the number of fields in each line of input in awk? Print nr or print $nf, print nf or print $0. So I'll wait for some time. I'll try to answer these questions. Okay, yeah, let's go question by question. What is the default field separator in awk? It is a new line. What is the syntax to print a specific field in awk? So the field is denoted by dollar field number, that is $1, $2, $3, like that. Which of the following is an awk built-in variable, that is nr? So nr refers to the current record number or the line number that is being processed. Then what does the command begin do? So this executes a command before processing input. And how can you print the number of fields in each line of input in awk? That is using printnf. So nf refers to the number of field in the current record. So here I have given link to get an awk. So there are a lot of built-in variables that are available, and also user also can make user defined variables to run awk. So these pages will help you to install the awk, and you can have some hands-on practice using any simple text file. Like you can create a text file having your personal details as an input, or your names, your names or different names as an input, and you can try to modify and get extract, use the patterns and also extract information from them. So even some of the demo files have given here. So these demo files are related to PDBs and all. One can use these demo files and the commands here or commands here, and try what is the data extraction manipulation thing that are happening with the awk.
Excuse me, please share the link for demo file in the chat box.
Yeah, I'll share it here. So some of the text file manipulation codes I have given to print all lines in a text file. So awk curly braces print and your text file.txt name. So print the lines containing a specific keyword, for example Bob. So awk pattern search for Bob and your text file.txt. Even you can add the print command here, but also by default when the pattern gets fetched, the default print command will work here. Next is count the number of lines in a text file. So awk end printed is current NR number, which refers to the current record number. So it will print at the end what is the NR number, that is a line number in text file.txt. So the first command is print all lines in a CSV file. So first the pattern of CSV, that is delimiter comma, has to be defined. then print in curly braces for CSV file. Then I have first and third column. So I told dollar symbol, that is field separator, is used. So $1 and $3 represents the first and third columns. Calculate.
Excuse me. Here, this F is not case sensitive
No, it is
because
case.
if I remember, Professor Gromeha has written F in small, and you have written capital F. So that means it is not case sensitive, right?
Yeah, it is not case sensitive, and also you have FS also will work. Like both, that is also case sensitive. We have FS and OFS. These are just field separator. So this you can either use caps or small.
Okay. Okay.
In
Thank you.
all commands, any flags, that is which starts with the hyphen, are case sensitive. Either capitals or small will work there. So to calculate the sum, so here in the conditional statement of curly braces we have used sum equals to, so this plus and equals to, what is the meaning of this is sum equals to sum plus $2, value at $2, that is value in field 2, and in the end print sum of column 2, what is the sum value in CS, in your input.csv file. So this command states that awk, the field separator or the delimiter of the CSV file is comma, then calculate sum. How the sum is calculated is sum equals to sum plus $2. So this sum value will keep on updating as we move along the rows in the CSV file, and in the end print sum of column 2. Next guys, print lines based on a condition where the value in the second column, that is second field, is greater than 30. So this awk-f delimiter is common. Here we are checking for a condition, that is $2 greater than 30 in your CSV file. Similarly, this command calculates the average in a specific column, and also last one, print lines based on the ranges, that is if it falls between field 2 is greater than or equal to 20 and field 3 similarly is less than or equal to 30, and comments means both the conditions has to be satisfied. So either this based on the format of the awk program, the curly braces or the high apostrophes, sorry, curly braces are used, or quotes can be, single quotes can be used.
Where do we use quotes and where do we use curly braces?
No, curly braces are important since I'm working with Mac. My system works with quotes, both are same, but in Mac systems the awk is different, that is something geawk, so it won't accept the curly braces, but in regular system curly braces should be used.
So in Windows it will work. Windows
Yeah,
or Linux it will work. Both curly braces and quotes both will work.
quotes both will work. So similarly I have here to print all the lines in PDB file. Next I have print specific columns in PDB file, that is column 3, column 4, column 7, column 8, 9, 10 and 11. So, and also this awk command here calculates the total number of atoms, that is total number of atom entries will be counted here, that is pattern search of atom count plus plus a count value will be started, and it is keep on iterating itself with a value of increased by value of 1, and at the end print total number of atom lines. Then we have average coordinates. So as we all know, in PDB format we have x, y and z coordinate, Cartesian coordinate system. So here command x plus, so 7th position is x coordinate, 8th position is y coordinate, and 9th is z. So this is similar to how you get sum from a column. And this command here shows us how you extract alanine atoms, atom related entries, and that corresponds to the amino acid alanine.
Excuse me, in the previous command, so it will give the sum, not the average, right?
No,
Uh,
no, yeah, sorry, this is the
so
sum.
okay, last in the last you are dividing by the count.
Here, this is count, plus plus is count. So the average, the printing is average. So next is range of values. So these are the commands that could be applied to these files that I have given in org demo. So and even I have given installation instructions as well. So here the next concept is developmental algorithms. So to start with, why development of algorithms is important in mathematics. So this part is critical for mathematics because it allows researchers to analyze and interpret vast amounts of biological data more efficiently and accurately. With the advent of high output technologies like next generation sequencing, it has become possible to generate enormous amount of genomic and transcriptomic, proteomic and metabolic data, but analyzing this data presents a significant challenge. So these algorithms play a crucial role in mathematics because they enable researchers to process and analyze and interpret large and complex biological data sets. These algorithms can be used to identify patterns and relationships within the data and infer biological function and predict the impact of genetic variations on biological systems. For example, algorithms can be used to align sequences, assemble genomes, predict protein structure and function, identify disease causing mutations, and analyze gene expression patterns. Without algorithms, it would be difficult, if not impossible, to extract meaningful insights from massive amounts of biological data generated by modern technologies. So, in summary, the development of algorithms is essential because it allows one to analyze and interpret biological data in more efficient and accurate manner, leading to new discoveries and advances in understanding the complex working of living systems. So, steps involved in developing a mathematics algorithms are: the first step in developing mathematics algorithm is to define the problem that the algorithm is meant to solve. This involves understanding the biological question or hypothesis that is that needs to be answered and identify the relevant data sources. Defining the scope of the project is also essential as it helps to ensure that algorithm is focused and the results are relevant to the problem at hand. Once the problem has been defined, next step is to gather necessary data for the project. This can involve collecting raw data from various sources such as sequencing data, gene expression data, protein interaction data, and other types of biological data. The data should be collected in a format that is compatible with the algorithm and should be sufficient quality and quantity to produce accurate results. After data collection has been done, it needs to be pre-processed to make it suitable for the analysis. This may involve cleaning the data, filtering out the noise and errors, and transforming the data into suitable format for analysis. The data pre-processing step is critical as it helps to ensure that data is accurate, consistent, and free of artifacts that could affect the result of the algorithm. Once the data has been pre-processed, the next step is to develop the algorithm itself. This may involve selecting an appropriate algorithmic approach, implementing the algorithm using a programming language or a software tool. So once the algorithm is developed, testing and refining the algorithm based on the testing performance to ensure that it produces accurate results. Depending on the complexity of the problem, the algorithmic approach This, tech, this step can take significant amount of time and effort. After algorithm has been developed, it needs to be validated to ensure that it produces accurate results. This may involve comparing the accurate algorithm results to those obtained by other methods or using the experimental data as a test set to test the algorithm's predictions. Validation is an essential step as it helps to ensure that algorithm is robust, accurate and reliable. Finally, the algorithm needs to be documented and disseminated so that others can be used as a web server or GitHub code or any programming file. This may involve publishing a paper describing the algorithm, releasing the algorithm as an open source software, or presenting the algorithm at conference or workshops. So documenting and disseminating the algorithm is essential as it helps to ensure the algorithm is transparent, reproducible and accessible to other resources. So these are the basic steps, and some steps may be followed and may not be followed according to the work plan, but still each step is critical and requires careful attention in detail to ensure that algorithm produces accurate and reliable results that can be used to advance our understanding of biological systems. Sorry, I've shown answer here, it's okay. So why is development of algorithms important in bioinformatics? So algorithms can help to analyze large amounts of biological data quickly and accurately, and also algorithms can identify patterns and relationships in biological data that may be apparent to humans, and algorithms can also predict the structure and function of the proteins and other biological molecules. So all these are the part of why it is important to develop. Then I have introduction to machine learning. Just give me a minute. So machine learning is a field of study that involves developing algorithms and statistical models that enable computer systems to learn and improve their performance on specific tasks with experience. Unlike traditional programming where explicit instructions are given to a computer to carry out a task, in machine learning the system learns out from the data and experiences to perform a task more accurately and efficiently over time. So these ML algorithms use statistical techniques to learn from data, identify patterns and make predictions or decisions based on the data. This process involves identifying relevant features, selecting a suitable model or algorithm and optimizing it to minimize errors and improve performance. The more data systems learns from, the more accurate and reliable its predictions become. Generally, people said ML to be part of subset of artificial intelligence, which refers to the broader field of creating intelligent systems that can perceive, reason, learn, and act like humans. So this artificial intelligence encompasses a range of technologies including robotics, natural language processing, and computer vision in addition to ML. ML has numerous applications across industries including healthcare, finance, e-commerce, and more. In healthcare, ML is used to analyze the patient data and predict the disease outcomes, while in finance, it is used to detect fraud and make investment decisions. So in e-commerce, companies use ML to personalize product recommendations and optimize pricing strategies. So we have different types of machine learning, that is supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. Supervised learning involves training a machine learning model on a labeled data where the inputs and outputs are known. The algorithm learned from this labeled data to make predictions on new or unseen data. The goal of supervised learning is to learn a mapping function from input variables x to output variables y by minimizing the error between predicted and actual values. So under the supervised learning, we have classification and regression problems that we'll see in some time. And then we have unsupervised learning, which involves training a machine learning model on unlabeled data where the outputs are not known. The algorithm learns to identify patterns and groupings in the text data to extract useful information without any specific guidance or feedback. So under the supervised learning, we have clustering and dimensionality reduction problems. So clustering is grouping of data, so where data points within the group have similar properties, and among the clusters there is no similarities. It is just like a CD hit. CD hit is also one of the clustering technique. And dimensionality reduction problem. Here, suppose you have a data set with large number of features, and you want to reduce the number of features without losing the important information. Generally, people follow two rules in selecting a number of features that could be used for ML model. So some people follow a square root. For example, if you have more than 81 data points, the square root of 81 is 9. So 9 features could be used. The combination of 9 features could be used. Or some people who work with larger data, or they use n divided by 4 or n divided by 5. That is, where is n is number of data points. So in this dimensionality reduction problem, the algorithm would learn to reduce the number of features by identifying the most important features that capture the most variation in the data set. So the most important features are either identified using correlation values or the mean absolute error values, or considering the feature value outlier conditions. Then we have semi-supervised learning, which involves training a machine learning model on a combination of labeled and unlabeled data. The algorithm learns from both the labeled and unlabeled data to make predictions on unseen data. So image classification problem. You have a data set of images of cats and dogs, but only some of the images are labeled either as a cat or dog. You would provide the machine learning algorithm with both labeled and unlabeled data. The algorithm would then learn to predict whether the new image is cat or dog by identifying the patterns or relationships in the data. So first it learns on the labeled data, then it tries to refine the algorithm using the unlabeled data. Then we have reinforcement learning, which involves training a machine learning model to learn from trial and error to maximize a reward signal. The algorithm learns to take actions in environment to maximize a cumulative reward over a time. So this reinforcement learning mostly is a gaming related problem. So here one would need to provide a machine learning algorithm with a game environment and a reward signal. So the algorithm would then learn to take actions that maximize the reward signal by trial and error. So this is an example of reinforcement learning problem. For example, reinforcement learning, when you play, you get hints, or a next step is auto suggested. So these types of comes from learning. Or when you play Candy Crush, if you wait for a 5 seconds, it asks you to suggest to make a move. As I mentioned, we have classification and regression as a types of supervised learning. Classification is a type of supervised learning where the goal is to predict a categorical output as a variable. In classification problem, the algorithm learns to classify input data into one of the predefined categories. That is, given a data point, it identifies whether it belongs to class A, class B, or class C. Then we have regression. In regression, the goal is to predict a continuous output variable. In regression problems, the algorithm learns to predict a numerical value based on its input features. So regression will give a real value or a numerical value as an output. Then we have types of unsupervised learning. So clustering is the one where the goal is to group similar data points together In clustering problems, the algorithm learns to identify patterns and relationships in the data without any specific guidance or feedback. So, clustering is widely used in business management or HRM, human resource management studies, for customer segmentation or anomaly detection. Then we have dimensional reduction. I think I have explained this. The goal is to reduce the number of features in the data while preserving as much information as possible. So I have a few questions here. So the question one is, what is the goal of machine learning? So it is to write programs that can solve any problem, or to enable machines to learn from data and improve their performance over time, or to automate all human jobs, to replace human decision making with automated decision making. Yes, so it is to enable machines learn from the data and improve their performance. So this learning process is called involves training algorithms to recognize patterns in data and make predictions or decisions based on that data. So what are the two main types of machine learning algorithms? Okay, so whether they are supervised or unsupervised learning, classification and regression, deep learning and reinforcement learning, or decision trees and random forest. Yeah, as the answer is mentioned, supervised and unsupervised learning. Which type of machine learning problem involve predicting a categorical value as a output? For example, consider whether an email is spam or not, whether it's regression, classification, clustering, or reinforcement. So classification is the one that is involved in predicting a categorical value. So which type of machine learning problems involves finding groups of similar data points? So it is clustering and predicting a continuous value. So it is regression. So here I have a question. When can a regression model is used for classification? How? Any idea? So regression, which is a real value prediction, how it can be used for a classification model. That is like how a continuous value can be converted to classes once a continuous value is predicted. imagine what happens if I convert all the labels to 0 and 1. For example, 0 is for class 1, 1 is for class 2. Then I apply a regression on it. So the value which is 0 or close to 0 could be treated as class 1, which is 1 and around 1 can be treated as class 2. But classification models cannot be applied to a regression problem, but sometimes regression model can be applied to a classification task. So I have a quiz here, that's all I have here. Here after some time, based on the time, we'll also see how validation on ML methods are continued. If not, this will be seen in the next class. So here the question 1 states that what command is used to print the alternative lines in awk. So consider the codes here has curly braces as well. Since I am using a Mac system, so I prefer using quotes, but in an actual, curly braces are preferred in awk programming. With the updates of the Mac, the curly braces are no longer supported in Mac, but they are supported in other formats. Yeah, it is C. The percentile symbol is used to print the alternate lines. So which of the following is a real value prediction in bioinformatics? So whether prediction of slow and fast folding proteins, or prediction of folding rates, prediction of high and low affinity protein-protein complexes, or prediction of stabilizing and destabilizing mutations. Which of the following is a real value prediction or a continuous value prediction in bioinformatics? So of these, option A, C and D are like classification problems. You can see slow and fast class of folding proteins, high and low affinity complexes, stabilizing and destabilizing mutants class. So the only left over option is B, which tells a prediction of folding rates, which is a value, real value prediction algorithm. So in printf statement of coding language, which letter is used to format as a strings or define strings? Strings is defined by s. F float. So given a real value prediction method, what are the best methods for assessing the performance of this method? Whether sensitivity, specificity, ROC and accuracy, mean absolute error and accuracy, or mean absolute error and correlation. Okay, so it is mean absolute and correlation, sensitivity, specificity, ROC, accuracy are the ones that are used in classification problems. Mean absolute error, correlation, root mean square, standard error, roots mean square, deviation are the ones that are used in real value prediction. So these concepts will be dealing with some problem calculations also in the next machine learning classes. But these are just for our understanding since sir has completed the week lectures on these. If the correlation between two sets of data A and B is 1, then data A and B are directly correlated or data A and B are inversely correlated. There is no correlation between A and B. There is some correlation between A and B. A and B are directly correlated. So which of the following is a classification problem in bioinformatics? Predicting the binding affinity of protein-protein complexes, prediction of solvent accessibility of residues, identification of binding sites, or all of these. So it is identification of binding sites, because binding affinity KD, as we discussed in previous lecture, it's a numerical value, which is, here we are not classifying the proteins or the complexes into any group. Next is solvent accessibility. Solvent accessibility is also a numerical value, like what percent of a area of an atom or a residue is accessible by solvent or it's buried. So it's again a numerical value. So here only identification of binding sites. So here the categorical concept is whether given a residue in a protein, whether it's present in binding site or no. Yes or no. Binding site yes or binding site no. So this is how it's a classification problem. So this is a basic question. Awk language was discovered by
B.
yes. So here I'll be just giving an intro to machine learning. So as we discussed, machine learning is based on idea that computers learn from data, identify patterns on their own without being explicitly programmed. It involves developing algorithms that can automatically improve their performance on a specific task by learning from examples or data. In traditional programming, a programmer writes a code that tells computer exactly what to do for a specific task. However, in machine learning, the computer learns to perform a task by analyzing and learning from large amounts of data. The machine learning algorithm then can use this learning to make predictions or decisions on a new data. The process of machine learning involves feeding large amounts of data into an algorithm and allowing the algorithm to learn from that data. The algorithm looks for patterns or relationships in the data that are relevant to the task at hand. Once the algorithm has learned from data, it can then be used to make predictions or decisions on new data. For example, in image recognition, a machine learning algorithm can be trained on a large data sets of images labeled with different categories, and the algorithm learns to identify features and patterns that can distinguish from the two classes. For example, we have given a large data set of images of cats and dogs from different aspects or different types of images or different dog breeds images. Once the dog breeds and cat breeds images, once the algorithm has learned from this data, it can be used to identify whether a new image contains a cat or dog. So this is a summary regarding this intro and other machine learning concepts, how validation is done. I'll be taking it next class. If any other questions now, I can take those questions. If no other questions, you people are free to leave.
So, to train the machines, do I need a command in programming or just a command in machine learning algorithms only?
See, actually, to make this training step happen or data pre-processing happen, there are some programming lines that one has to do, but they are simple one-line and two-line commands only, which are by default. If you are using a particular ML algorithm, the defined set of lines have been present. So use.
So already existing machine learning algorithms for some other data sets. So maybe using that I can apply for my biological data set.
Yeah, see, that's what no ML algorithm here. How can I tell is the steps the others have used to develop. For example, recently one might have developed how to predict the stability of a protein. So similar steps could be followed to find out how the binding affinity of the protein. It's like steps are similar, not the similar algorithm will work for everything. Algorithm is the one that is already trained on a specific data. For example, it's like a player, like who is trained in one sport cannot perform in other sport. The same code lines you can use, just change your data set there, the code will work. But the developed ML model will never work on a new data set.
So using the same code, I will train the machine with my data set, and then I can use it for the test data set.
Yeah, you can use it for test data set. That is test data set is validation. And if you have any new data, you can predict the outcome of the new data using that model. And there are different ML algorithms as well, right? Starting from basic linear regression techniques, we have very highly advanced MLP, that is multi-layer perceptrons, deep learning methods, neural networks, convolution, graph neural networks and all. So I'll also try to give introduction because I have two more classes after this. So mostly these two more classes are focused on machine learning also, and in one of the class I'll also show how without coding one can obtain a ML model or see this ML validation results. Once I cover these basics, then I'll go for demo of that as well.
So in that case, I can use that data for other data sets also. For example, metabolome data or proteome data.
Yeah, see, generally machine learning models are sequence based or structure based. So either people give them the transcriptome data, metabolome data, protein data, proteomic data, or individual proteins, protein 3D structures, DNA sequence, RNA structures, RNA sequence, anything. So it's like based on what aim. Like if my aim is to predict the stability of a protein using sequence, then my input to the code will be protein sequence. If not, my aim is to predict protein stability using 3D structure, then my input to the learning, my input in training data set will be either PDB ID or a PDB structure of a protein. It depends on how we are aiming to make a ML model. And mostly in biology, most of the machine learning models or deep learning models are generated based on experimental data. For example, various databases are available where the information from multiple experiments on multiple proteins that is available. For example, we have discussed Protham. Protham is for thermodynamic information of protein. So it contains more than 30,000 thermodynamic data from more than 1200 proteins. So then I can make for a protein for 100 proteins, I can have the delta G values, delta H like enthalpy values, entropy values, melting temperature values. So if I aim to predict the melting temperature of a protein to my system, I'll give some protein related features, for example sequence related features, amino acid composition, structure related features like what is the hydrogen energy or number of hydrogen bonds in the protein, what is the volume of a protein as an input. So if you consider each row, the melting temperature of protein A, the first value in a row, followed by set of features like feature 1, feature 2, feature 3, feature 4, set of features as an input to ML algorithm. The model will learn the patterns, how amino acid composition is relating with melting temperature, on how the energetic parameters are relating with melting temperature, Then it tries to build a regression algorithm, that is y equals to f of x. A regression equation it will try to build. Using that regression equation, we can calculate for a new protein what are its features, apply those features in it, then calculate its melting temperature without doing any experiments. So this is one simple example and mostly what I work on. To similarize or to simplify mostly this, people used to do protein estimation or carbohydrate estimation where they use standard concentration, and then they have UV readings which are plotted against x and y. If a new data point is found, they trace back. This is also a simple machine learning method that we do using pen and paper. So first the standard are used to make a graph, that is you plot them, like you make a line is nothing but some y equals to f of x equation, mostly y equals to mx plus c kind of equation. Once you have a equation and you know the new y value, you wanted to know the concentration corresponding to that new UV reading, so you just trace back along the line to the x axis, you get the new concentration. This is also a similar machine learning concept. The details on machine learning, how the graphs are shown, everything I'll be showing in the demo of Veka, as well as I have some problems. I'll be dealing all those in that next class. And final class will be summary, which I have planned to take on 15th. I expect here.
15th April.
Yeah, 15th April. After my 12th week class, next day there is one summarizing class, just like how Professor Grome has taken summarizing week lectures. We'll be also doing the same. Yeah, it's 15th.
Okay, so two consecutive classes, Monday and Tuesday.
Yeah, Monday will be this machine learning related,
Regular class, and
regular class.
Tuesday.
Yeah.
Also, please share the link for this AWK programming to download the in the chat box.
So you are using a Windows system.
Yes, Windows.
This is for 32 Windows. If your system is 64, just download the next link. Okay. This is for 32-bit system. You can also get it. It will also work in 64. But if you are using 64, better to download the 64-bit. Just in the same link you will find down. You can download this original source, and you have general installation instructions, and if you see any error, how to change the paths and all, you can use this GNU Win 32 help.
This is very old,
Yeah,
2008. So this is the last one. I can use that only. Huh?
actually the link is for 32-bit. Even you can just go, just type, you will get all the ones. This is the last update even I expect here, 3.1.6. So now many of these tasks are performed using Python or R programming only. Since awk is part of the course curriculum, I tend to take a problem solving session on awk as well. But whatever the task we do with the awk, similar task could be achieved using Python or other programming languages as well.
And Linux also.
Yeah, Linux is an operating system. Awk we have for both Windows, Linux, and Mac. I,
So, what is the advantage of awk if the same task can be performed with Python or other languages?
yeah, so the the printing, it could be integrated with terminal. Not all the Python versions could be integrated with terminal, but this awk can also be integrated with terminal. See, many of the biological tools or software what you see, they print in that your terminal or command prompt, so it can read from the command prompt and provide. And it's in some for biological fetching of patterns and all, people consider awk to be faster than other programming languages. Yeah. In my personal
Still,
experience, I feel
if
awk is better than R, but it's in par with the Python as well. It's in the same performance par with Python.
you said
R
R, the statistical language, R.
R programming, yeah. For this pattern fetching and all, R might take little more time considered than Python and awk.
So even though it is very old, 2008 is the latest version. So still, people feel awk is better than many other languages.
Yeah, like possibly people feel that, but I'm not sure how much current people are using this. But still, it is good. We use in our lab awk programming for some of our purposes, and we learn programming not only for current use, it's also to understand how the old methods have developed. For example, if we see the publications that are present around 2000, 2005 and all, most of them are based on JavaScripts or C programming. So without basics of those, we can't understand where the research has started and how a research problem has been solved using programming. The first stages of learning cannot be understood without the knowledge of programming. So why we learn old programming languages is to understand old research studies in that areas. Yeah, so here if you observe, still people, there is a recent Stack Overflow question on July 2023 as well.
Okay, thank you for the class.